Have you ever noticed how your hair sticks up after it is rubbed with a balloon, or how your clothes stick together after they've been in the dryer? Both of these phenomena are examples of electrostatics.
Electrostatics, the study of electricity, or static electricity. This printer is a prime example of how electrostatics is used in everyday life.
The circle on the left has positive charge, and the circle on the right also has positive charge, which means they have like charges, which is the same charge. This causes the two circles to repel each other. The circle on the left has a positive charge, and the circle on the right has a negative charge. Because these two charges are opposite, the balloons will attract and move towards each other. Opposite charges always attract. For this experiment, you will need a roll of tape, a table. Rip an approximately 20 centimeter piece of tape off and fold over the top. This tape will be your bottom tape. Lay the tape on the table and label it B for bottom. Cut another piece of tape, also approximately 20 centimeters, and put it on the table. This tape is your top tape. Label it T for top. Now, rip both pieces of tape off the table. Check to see if it's charged. Rubbing your hand into the tape. Okay, if the tape doesn't attract, it means it's not charged, so you can rip the tapes apart. Now, hold the tapes close to each other. Notice they attract. Your materials for this demonstration are wool, paper ripped up into small pieces, and a ruler. Step 1. Rub the ruler with the wool to charge it. Step 2. Touch or hover the ruler above the paper to see the attraction. Notice how paper sticks to the ruler. Some of it. Now watch again. Once again, paper is attracted to the ruler because they have opposite charges. In this case, the wool lost electrons and gave it to the ruler, and the positive paper is attracted to the negative ruler. Rip the two top tapes off. Be careful to only rip the top tapes and not the bottom tape. Now, hold the top tapes close to each other. Notice how they repel and move away from each other. They were prepared in the same way, which means that they have the same charge. And like charges will always repel. Have you ever wondered why you probably shouldn't go swimming when there's a thunderstorm? Or why workmen have to wear rubber boots when they're working with electricity? Conductors and insulators explains this all.
Conductors are materials that allow electrons to flow freely, like the legs of this chair, which are metal, or like the water from this fountain.
Insulators are materials that don't allow electrons to flow freely through them, like plastic, like this ruler, or this pen, or glass, like this window.